Welcome to the lesson on designing studies. Today we're going to discuss sampling and surveys. Our vocabulary: population. This is the entire group in a statistical study that we want information about. Sample. Sample is the part of the population from which we actually collect information. We will use this information from a sample to draw conclusions from an entire population. Now let's discuss some examples of sampling. The problem: we are going to identify the population and the sample of the following settings. A furniture maker buys hardwood in large batches. The supplier is supposed to dry the wood before shipping. Wood that isn't dry won't hold its size and shape. The furniture maker chooses 5 pieces of wood from each batch and tests their moisture content. If any piece exceeds 12% moisture content, the entire batch is sent back. Okay, we need to identify the population in problem A and the sample. Well, the population in problem A is going to be all of the hardwood in the batch. And the sample is going to be, let me make sure. The sample is going to be the 5 pieces of wood chosen. Okay, the next problem. Each week, the Gallup poll questions a sample of about 1,500 adult U.S. residents to determine national opinion on a wide variety of issues. Okay, the population for this situation is all of the United States residents. So all U.S. residents. That are adults. And the sample is going to be the 1,500 adults chosen. 1,500 adults chosen in the U.S. Next, we're going to discuss sample surveys. First step in planning a sample survey is to say exactly what population we want to describe. Let me go ahead and spell describe correctly. Second step is to say what we want to measure. We need to give an exact definition of our variables. And final step is to decide how to choose a sample from a population. Let's just discuss an example that we may do on occasion: sampling ice cream. We head into an ice cream store. There's a new popular ice cream out, but we're not too sure if we like it, so we ask for a sample. That sample of ice cream, since ice cream tastes pretty uniform, I mean, one scoop out of a batch of ice cream is going to taste like the whole batch of ice cream. So that little sample we're tasting is our sample, and then let's say we like it, we order the whole cone, which would represent our population. How to sample badly. The easiest, but not the best, sampling method is to just choose individuals who are close by. An example: let's say we're interested in finding out how long students at a large high school spent on homework last week. We go to the library and ask the first 30 students about how much time they spent on homework. Well, this is called a convenience sample. It's a sample selected by taking the members of a population that are easiest to reach. Convenience samples often produce unrepresentative data. What's wrong with our convenience sample of students in the library? It's unlikely the sample represents the homework habits of all students at the school. In fact, we'd expect the sample to overestimate the average homework time in the population, since students who hang out in the library might tend to be more studious. This brings up the point bias. Bias is using a method that will consistently overestimate or underestimate the value we want to know. Voluntary response samples. They consist of people who choose themselves by responding to a general appeal. Voluntary response samples show bias because people with strong opinions often in the same direction, are most likely to respond. Write-in and call-in opinion polls are good examples of voluntary response samples. How to sample well. Random sampling is a sample chosen by chance. A sample chosen by chance rules out both favoritism by the sampler and self-selection by respondents. Simple random sample, or SRS, is individuals of a population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. Let's say I want to draw a sample of team leaders in my class, and I need 5. So I put my 32 names of all my students in a hat, and I select a sample of 5. That means all 32 individuals have the exact same chance of being drawn as the 5 that actually are drawn. Let's discuss stratified random sample and strata. To select a stratified random sample, first classify the population into groups of similar individuals called strata. Then choose a separate simple random sample in each stratum and combine these simple random samples to form the full sample. What does all this mean? Well, take for instance, we want to study the sleep habits on school nights. And the population of students in a large high school might be divided into freshman, sophomore, junior, and senior strata. And then within each of those strata, then we do simple random samples to monitor or find out the sleep patterns of high schoolers on school nights. How about cluster samples? To take a cluster sample, first divide the population into smaller groups. Ideally, these clusters should mirror the characteristics of the population. All individuals in the chosen cluster are included in the sample. Example of a cluster sample, let's go back to the high school. Imagine a large high school that assigns its students to homerooms alphabetically by last name. The school administration is considering a new schedule and would like student input. Administrators decide to survey 200 randomly selected students. It would be hard to track down an SRS of 200 students, so the administration opts for a cluster sample of homerooms. The principal, who knows some of the statistics, takes a simple random sample of 8 homerooms and gives a survey to all 25 students in each homeroom. That is an example of a cluster sample. Inference. The process of drawing conclusions about a population on the basis of sample data is called inference because we infer information about the population from what we know, not form. Sorry about that. Another little spelling error here. From what we know about the sample. What can go wrong? Sampling errors. Margin of error tells us how much sampling variability to expect. Undercoverage occurs when some groups in a population are left out of the process of choosing the sample. Example, a sample survey of households will miss not only homeless people but prison inmates and students in dormitories. An opinion poll conducted by calling landline telephone numbers will miss households that have only cell phones, as well as households without a phone. The results of a national sample surveys therefore have some bias due to undercoverage. A sampling frame is the list from which the sample is actually chosen. Now there are also non-sampling errors such as non-response. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. And then there's also response bias, when an individual gives an incorrect response. An example of response bias is if individuals were asked if they voted, feeling guilty that they feel that it is their civic duty to vote, actually lie and say they voted when they in reality did not.